looks like Quirk version 2.3 is out. um, I wasn't surprised to see that today in Twitter. So as soon as I had time, I actually uh, jumped into it. Let's see what the release note says. So added formulaic X, Y, and Z gates which can have their rotation angle set to a custom constant equation. That's pretty cool, especially the equation part. I mean, I haven't really found a sort of an example myself where I would like to use that from like with an equation, but constantly, definitely, it allows at least not to have to create custom gates every time that I would like to have like um, a rotation, like a Z rotation, for example. Let me see if I can just try that. I guess those are these ones here. And I see the hidden phase. I see that in Twitter as well. That now we have global phase instead of hidden phase, which okay, so kind of confirms what I was suspecting, that this is the global phase. Okay. Mhm. Which kind of weird because if I remember well, it does indeed add sometimes. Oh, but I'm not so sure if this is the same. Oh yeah, here it's now written global phase as well. But if I remember well, 180 degrees angle. If I now add a 90 degrees, yeah. So it actually exactly. Yeah, it's basically yeah, it's basically a global phase, which in some cases helps us correct if we want a particular phase to be zero, for example. Um, cool. Okay. Um, so we've got these formula gates basically, which, if I understand this well, so what the formula is, you're allowed to use also some stuff. I don't know if it's written here because in Twitter, what? Remind me later. Isn't it written here? Because it could use the sinus, cosinus, and other stuff, and then there was like constants available, like it was E, it was I, but they're not here. Yeah, whatever. So you can basically, for example, so this is phasing one. So it basically rotates around Z by an amount determined by a formula. Because before you had only the Z, the S, or the T gates, and then you had a spinning gate. Um, so this is basically the same like the spinning gate, but you can parameterize that. And actually, you can so by default it's the sinus of pi times t, but you can actually, oh, here we have available functions, sinus, okay. Operators plus minus division, plus the multiplication, division, minus, and exponentiation. So you can use the variable t, and then that turns it into one of those dynamic gates, but I think we don't have to, right? So I can say 2 times pi, no, or pi. Yeah, and then now that's z to the power z pi, which if I turn into 1, then it adds that phase, and I can click and change. That's pretty cool. Mm-hmm. Sinus of pi. Cosine of pi. Yeah, and that is 180. Cool. So now you can make it basically constant. But what I don't know is what does this represent? Z gate's exponent, because a time variable is it that because here you've got the S by 90 degrees. It's definitely not angles directly. Is it that this is the so if I Google for Z rotation, what's that? The Z gate matrix phase gate matrix. Let's see. Here you have. Is this anyhow related? It's like, what's the parameter defining? Is it defining these, this element in the matrix? That, so literally, you're literally just adding a phase. So what if, for example, would say phase gate 180 degrees, or Z gate matrix. Pauli Z gate. Yeah, it's a -1. Okay, that's what I meant. Yeah. Okay, so let's see. For example, if I would say, I just want to check that. So an example is the T gate is pi divided by 4. T gate is pi divided by 4. So a T gate, that's 45 degrees, pi divided by 4. If I do that and I say pi divided by 4, no, I'm gonna still divide that. If it's pi divided by 6, 6 pi divided by 8, and 12, then that's also not. Is the is that I have to say Z E. How do I make this power sign with my keyboard? E to the power of I times pi divided by 4, that formula. No, but that's probably not going to be. Why is it but formula? Because of the brackets? Oh, because I is not available. Yeah. But then then I don't know. Defined by a formula and rotates around z by angle in radians determined by a formula by an amount. So is the amount degrees? Rotates around z by an amount determined by a formula. Maybe that's just the degrees. So if we have maybe I'm just making it too complicated. If I have a t, okay, so t is z to the power 1 divided by 4. So if I do these to the power of 1 divided by 4, that should be it. Okay, I get it. So it's literally the amount. So if I would say z to the power of 1, that's is that z? Let's say z to the power of 1. Yeah, that's it. Yeah. So it's then you can define just fractions of that. So z, if I do z to the power, what happens if I do 2? Yeah. Okay, cool. Get it. So it's kind of proportion to that, and then you can do the same with y and x. So it's basically the rotation, but it's not in angles. It's an amount. So it's in proportion to what the y gate does. Original in this case, right? So y of 1 is this, and exactly. But then half y is the square root of y. That's this. And if I do 1 divided by 2, it's this. Yeah. Wait a second. Why they are pointing outwards? Yeah, it's the same. Cool. Perfect. Good to know. And then you have the RZ, RY, and RX. So this has been this is one of the places where I've got still some blind spots, I think, because I used to confuse these for these a lot. The difference being that I kind of see now is that this has the global phase that basically keeps correcting it so that 0 is transformed into 0, so it's not affected. While the Z rotations affect, they have no global phase, so they actually phase both terms, the 0 and the 1. And here it rotates around the Z by an angle in radians determined by a formula. So here we're really talking about the angle. So if I say I want a Z rotation of 180 degrees, right? That's gonna, oh, sorry, it's in radians. It's in radians, okay. So I'm curious why was radians used when most of the other stuff is expressed in degrees. I mean, if you, at least for this tool, if you take a look at the way this is explained in the gate, I guess because radians is what's used academically, and so I think that makes it easier to reproduce certain circuits in papers. Probably that's the reason. So if I say, for example, that I want pi, radians, then I'm gonna get this, which is the same if I would make a custom gate and I would say I want a rotation on the z-axis and I want 180 degrees. So here's in degrees, but I want no global phase. And so I will call that RZ 180. And so, yeah, that's the same. Cool. Good, so what's next? The parity gates. So this we covered, right? Yeah, rotations. Why rotations? Okay. So this we covered, and then we've got, I mean, we had that, those, I wonder, these are not replaceable at all because this is simply rotates a target by an input a divided by 2 to the nth of a half turn around the z-axis. N is the number of qubits in input a. Exactly. So I parametrized by not by a constant, but by an input a. I haven't played with those yet, but probably I should put out another video. The parity, so includes a qubit z observable in the column parity control. Gates in the same column only apply if an odd number of parity controls are satisfied. The way that I think this works is, so if you add the z parity and the z parity, and then you say you want to apply a not conditional to that, right? That is only going to happen if there's an odd number of satisfied parities. So if I put a 1, that negation happens. But if I put another 1, then it doesn't happen, because now it's an even number of gates of controls that are satisfied. What's interesting is, what if I put a plus? So, okay, so basically you will have, oh, and I see that there's the decimal now here. Also, it says amplitude 110 decimal 6. Okay, that's nice. So basically, it will happen for the case where the first wire is measured to be 0, because it's in a plus state, and here that's why we see a 116. The first one being the third wire. And here we see the first qubit is a 0, so this is the third wire. So this is where it doesn't happen, because in the first case you've got a plus. And you can also I want to keep that 1, and you can actually an X parity control, for example. In this case, wait a second, I thought that would happen 1 1. I thought that would happen only for the minus, honestly. For the minus, then it never. Oh yeah, of course. If there's a minus, then it never happens, because minus satisfies the X parity gate. So this means that this gate is satisfied always, and this gate is satisfied always. So we get that state in which the third wire, so the first qubit is always 0, and you've got 1 0 and 1 1, because basically this is what you really get if you take a look at just this, right? Yeah, cool. So I think basically in the release notes, if I find them again, because I should have come back here. So okay, this is checked. So checked. Party controls which are satisfied as a group if a number of them are satisfied. Check. Remove the sampling display, the mystery gate. Oh. And the sampling display, I honestly don't remember what that was. So it probably didn't hurt to remove it. I think there was something where it was just randomly showing you. So the mystery gate, it was the random gate, I think. Oh, and the 8 turns as well. Yeah, they're not that popular. I think the half turns and quarter turns are more popular. Holding Alt while dragging will now replace gates with their alternates. The alternate is often the inverse. Okay. If I do Quirk, so if I have, for example, let's say an S gate, and I press Alt and click. Okay, so this kind of, it's just a usability. So what if I, okay, so does it work with measurements? No. Yeah, indeed, there's one display missing. There's also not, this turns into that, makes sense. Does it work for the QFT gate even? Yeah, nice. I guess input A doesn't work. Maybe +1 will turn into -1. Yeah, cool. Will that turn into, yeah, the sign is changing. I guess those things won't be affected. Oh, it is indeed affected. Minus. Okay, so sort of, yeah, the opposite. But then Z will not turn into Z-1 because basically it's the same. Okay, cool. And the X and the Z party, it would be cool if they would turn into the, even number being satisfied. Okay, the controls probably switch on and off. Nice. The eyes turn into minus eyes. Oh, I'm curious about this. Probably. Oh, yeah, nice. Okay. Does this work for the spinning gates as well? Beautiful. But I guess it doesn't work for the neg. Really, negate. Now I get it. Negate. Spacer, the nothing gate doesn't turn into the everything gate, I guess. But what about these ones? Maybe the square root of I. Yeah, square root of minus I. Cool. Why do they have this funny shape? I haven't seen that shape anywhere else. Anti-imaginary gate. Half anti-imaginary gate. Nice names. What about these things? I haven't, like, this, he keeps clicking, saying click. I don't know why. I guess I'll explore that at some other point. Cool. So that's another one off the list. We got that. Move the silly section to the bottom. Okay, yeah, and rename it as color and expand it to include I minus Y and square root. So we just saw this. X and Y axis post selection gates now use symbols that match the input state symbols. I've seen that as well. So they use this. Exactly. Middle clicking the initial state of a wire. Maybe that's because you saw me clicking all the time. Middle clicking the initial state of a wire now close it to 0. Yeah, that's definitely helpful. I haven't. The thing is, I'm using a trackpad, so I can't middle click, and I'm using one of those trackpads right now because I don't have a mouse usually with me, and I haven't figured out how can I middle click with that. There's got to be a way actually, but you probably have noticed in a lot of my videos I'm just doing that because I want to go back to 0, or I just want to maybe switch between zero and ones, and then if I would just misclick or click like one time too much, then I would just have to go back to zero. No, but I can't. Can I middle click with this thing? I think I cannot middle click. I mean, whatever. I'll try it. Sometimes I use a mouse, and then it's probably useful. Should always have a mouse with me, I guess. All display state tooltips now include the decimal equivalent. Oh, we saw this. We saw this now. Fixed amplitude displays not normalizing and coherent condition results. Didn't realize about this at all. Fixed amplitude displays not showing assuming deferred measurement warning. Haven't explored that either. And fixed column dragging not working on OS X. Not something that I. Okay, fixed a Travis CI breakage due to export display being deprecated. Okay, there. Cool. That's awesome. I'm super happy, as I said in Twitter, that the tool is being further developed. I'm curious at what point this will become something that would need to be. Because what I like about this tool is that it's just so. It doesn't have any friction, and you can just have it in a browser. You can even have it. You can save it like work offline. That is really cool. You can create custom gates in many ways, and it's just all there, right? But at some point, if you keep cluttering, I guess, with different ideas and different gates, but I think most of the stuff that's been added makes total sense. I think that definitely makes life easier. Um, yeah, cool. That's really nice. That's definitely really nice. It works on mobile. That's, I think, probably I'm wrong, but I think it's one of the only tools that, if not the only, that I've seen so far that actually works on mobile in a super smooth way. Perfect.